Hi everybody, welcome to another lesson, angles in standard position. So the first thing you should know is what is angle. In geometry, one angle is formed by two rays with a common endpoint, and in trigonometry, angles are often interpreted as rotation of a ray, like this. So if our ray is rotating from this point to this, going to this side, going to this side, this is one angle that is formed here. Perfect. So you should also some terminology that you need to know: the initial arm and the terminal arm. Both of them are very important. The initial arm is always on the x-axis, like starting from the x-axis, and the terminal arm can actually end up somewhere in the x and y axis quadrant, either quadrant 1 or 2 or 3 or 4. So it's depend on that, terminal arm end up, the angle will be represented there. For example, if we have the starting initial arm is this one on the x-axis, and the terminal arm is this one in the quadrant number 2, so we would say this is our angle alpha, theta or alpha. Good. So now let's us see what is angles in a standard position. So one angle is called to be in standard position if actually its starting arm start from the x-axis and the end arm lies in one of the quadrant 1, as we said before, 1 or 2 or 3 or 4. So, and if these two arms have the same origin point, and it has a starting point, and it goes over all the way over this repair, we can say this is a standard position. So same thing, let's check this one. So we have the starting point arm from this side, we have the same end point, and we have the second arm lying in quadrant 1. So it is in a standard position. All these three are actually in standard position. However, if you look at these ones, the starting point is not at the origin, so we cannot consider it. Also this one, the starting arm is not on the x-axis, so you wouldn't consider it as a standard position. Same thing, this one, the starting point is out of the origin point, and the arm is not on the x-axis, so it is not considered as standard position. This is not a standard position, this is a standard position, this is not a standard position. Okay, now let's talk about some there is some we can say as a theorem. The sum of the angle of any triangle is 180. So it doesn't matter how the triangle looks like. It doesn't matter how the triangle position is. The sum of its three angles, it always end up to 180. So if you are given, for example, this triangle, and they are giving you this, you know this is 19, and they are giving you this as a 30, you automatically know that the other one is 60. Or for example, if I give you this triangle, it's not just a regular triangle, you know this is 90, and I told you this is 15, so you will know the other one is 180 minus 180 minus 90 plus 15, and you will find the other one. So angles in standard position can always be between 0 and 36 degrees, because if the starting arm is on the x-axis and in the end arm is on like the first quadrant of our x and y axis, we can see the angle is between 0 and 90. So this position is 90, from here to here is 180, from here to here is 170, from here to here is 360. So if you just are given just this figure, and they are asking you like this angle theta, like can you find the angle is between what and what? You can automatically say theta is between 180. Theta is between 0 and 180, or even 19 and 180, like in this quadrant. Reference angle. This is a very important concept that you need to learn, the reference angle. So the reference angle is defined as any acute known angle. Choose vertex between the origin, it's the origin at the origin of the x-axis, and those arms are the terminal arm of the angle and the x-axis. So if you are given any angle, immediately you look at the end arm, the terminal arm. So from there you can see is it like the projection of this terminal arm will be on the x-axis the right side, or in the x-axis the left side. So for example, for this one, because the projection of the x-axis is on the right side and the starting arm is in right side of the x-axis, so theta is same as theta r. The original angle is same as the reference angle. In this case, the terminal arm projection lies on the left side of the x-axis, so you can see that your reference angle start from the position where the terminal projection lies on, and go up until you touch your terminal arm of your original angle, and that will be your reference angle. For example, if I just have this example, I will just choose one example like this. For example, I have a pair like this. Okay, this is my x and this is my y. So my if I said that my angle is this, so this is my angle. So start for it starts from the x-axis and it goes all the way and it touch my terminal arm. So this is my theta. What would be my reference angle? My reference angle, I will just look at my terminal arm. I project it on the x-axis, and from there I start marking or repairing my angle. So my theta r is this one. So this will be my theta r. So let's us see other example. Same thing, like we just did one like this one. So same thing here. If my starting arm is here and my terminal arm is here, I will just do a projection of my end arm, and from there where it starts, I go and touch my terminal arm, and it will give me my my reference angle. For this, this is just an example which they are giving us the reference angle, and they are asking us to find the original angle. So in this case, if you are given the reference angle, which is this one, this is our reference angle, 20. The only thing I need this, I know this will give me my terminal arm. Okay, without looking at anything, I will just go from the right side of my x-axis and draw until I touch my terminal arm, and that will be my theta. Another example, if you are given one example like this. This is your x-axis, and this is your y-axis, and this is your, oh my god, what is this? And this is your y-axis. So for example, suppose we are given this angle. I am giving you a reference angle like this. So your reference angle is this. So this is my reference angle. So I'm asking you to find the original, to find the original angle. So this is my theta r. Oh my god, this thing is just not. This is my theta r. So I'm asking to find the original angle. The only thing you need to do, this is your terminal arm. Okay, you just go to start from the x-axis and draw an angle up to your touching your terminal arm, and that will give you your reference, your original angle, which is theta. For example, another example, because when you are given one reference angle, this reference angle can take four position. This position always, like, remember this, if you are given a reference angle, your reference angle will always be represented in four position. The first position is like this. So this is your first position. The second position is like this. So my first angle is this one. Same angle can be represented here. Same angle can also be represented here. Same angle can also be represented here. So this shows us that if we have one reference angle, keep in mind that reference angle can be represented in four different positions. Why? Because our reference angle is actually a projection of the original one over the x-axis. So I can have a projection on the x-axis in this position. I can also have a projection of the x-axis in this position. Same thing projection in this side, projection in this side. So just to remember, if you are given a reference angle, that tells you that you need to draw 4 different positions. One of them will be at the right side of the x-axis, one of them will be at the left side of the x-axis, one of them will be downside of the right side of the axis, and another one will be downside of the left side of the x-axis. And from there you can immediately know your original angle, just going from the starting point on the x-axis up you touch your terminal arm. Same thing, I start from here, I touch and I stop. Same thing here, I start and I go up until I touch my terminal arm and I stop. Same thing here, I start from here and I go up until I touch my terminal arm. I should not go in this position. If you go into this position, your theta will be negative. Should not be positive. If you're giving me a theta positive in this side, you should go from this side and go the opposite of clockwise side until you touch the terminal arm. So there is some specific some speciality about right triangles. So imagine you have a square. You have a square like this that have all its cotae are just 1, 1, 1, 1. So we can draw a hypothesis from this side to touch the other side and say and find it. So to find the hypothesis in this section, you use the Pythagorean theorem and you will find it. It's actually this one square plus this one square plus this one square is equal to this one square. And you can isolate for this one, which you can see here. C square is a square plus b square, okay? And you just isolate for c square. And in this case, you will find it's square root of 2. So the angle here, it's 45. Why? Because, as we said before, our original square is a square. So it has a square shape, which has a 90 degree in all sides, all 4 sides. So the half of 90 degree is 45. So my 45 degree angle can actually give us some information about the sine. We can find the sine, the cos, and the tan of my 45 degree, which will be, because the sine is the opposite of the angle divided by the hypotenuse, and no, divided by the hypotenuse. So the sine is the opposite divided by the hypotenuse, and the cos is the adjacent divided by the hypotenuse. And you can know that from your SOHCAHTOA method of memorizing this from last year. So same thing here. If you use another shape, which is equilateral triangle with a side length of 2 units instead of C here, you have a side length of 2 units, which is this one, and you know your cotae is 1, and you can easily find your B. So this is A, this is B, this is C. So C square is A square plus B square, and you can isolate for your B to find that is actually square root of 3. From there, you can find how much the sine and the cos of 30 degree and of 60 degree, and you can apply them. For my advice from my side, always remember this numbers. The sine of 60° is the square root of 3/2. The cos of 60° is a half, and you just switch them with the 30°, because you need that a lot in the unit circle. So this is just a simple example which I is asking you to draw 36°, 210°, 315°. I'm not going to go over that because it's so easy. I will just show you like, you know that your 210 is more than 90° and is less than is more than 180°, and it is less than, let me use this thing. Okay, so this is my repairs x and y. So my 210, this is 180, so I will just add a little bit to arrive to my angle, which will be 210 somewhere. So if I want to find exactly how much is 210 minus 180, and it will give you 30°. So this is whatever I am adding here is 30°. So I will go 180 and add 30°, and you can see it from here, from this representation which is here. Same thing here, you just do the same thing, and you will see that is it is giving you that this figure. Okay, now determine the reference angle. Determining the reference angle is just the whatever I show you before. You have your original theta, which is 130. You have your original angle, which is 130. This is 90. So my 130 will be here. So this is my theta. So my reference number, it will be just projection of this over the x-axis, and I will go from here. I will go from the x-axis and draw my theta r. So this is my theta r. Okay, so okay, this is your theta r, and yeah, if you want to calculate just 180 from going from here up to here, 180 minus 130, it will give you 50. You do the same thing for this one and this one. Okay, determine the angle in standard position. Determine the angle in standard position when one angle of 40 is reflected. Okay, in this case they are asking you to find, you have one angle of 40° like this. Okay, so this is your 40°. So this is your 40°, and they are asking you if it is reflected over the y-axis. So this is the y-axis, so this is x-axis. So if you reflect this angle over this side, your new angle will be like this. So this is your 40° reflected on the other side. And they are asking you determine the angle in standard position when, okay, reflected. So if I reflect my angle to this section, to this direction, so my standard angle won't be just this one, it will go up to here. So this will be my, so this will be my angle theta. So because it was just served, but when I reflected my terminal arm over there, I always keep my starting arm in the same place. So my starting arm will always be in the same place, but my terminal arm is reflected. Same thing if you reflect your terminal arm to this side, which is number C, this one, you'll get your angle starting from here and going up to here. This is your theta. If you reflect your 40 degree over the x-axis, your 40 degree will be like this. So this is your 40 degree. So this is your 40 degree. So the angle will start from here and go all over to here. Or this will be a positive theta, but if you show me the other one, which is this one, it should be a negative theta. Okay, so now this is just one application of the SOHCAHTOA problem, so I will leave you doing that by yourself. So now let's us do some exercises. In each case, decide, explain, is the angle is in standard position or no. This is no. Why? Because the original is not in the origin of the x-axis. This is yes. This is no, because my starting arm is not above the x-axis. This is yes, this is no. So without measuring, match each angle with each image. This is very easy because this one is less than 90, so you will know which one is less than 90 is this one. This one is bigger than 180 and is bigger than 180 and is less than 270. So which one is bigger than 180 and less than 270? It is this one. This one. So it should be bigger than 180. And you apply the same thing for the other example. So in which quadrant all these angles are represented? This one will be in the first quadrant. Why? Because if I draw my quadrant like this, so 48 degree will be actually somewhere here. Okay, so this is less than 90 degrees, so it will be in quadrant 1. Same thing for this one, 185. I know this is 180, so my angle will be more than 180, so it will be 185 somewhere here. Okay, for the other one, 220, same thing. This is 270, so it will be something like that. Okay, 160 is less than 180, so it will be somewhere. This is 160. Okay. Okay, this one also sketch angle standard position, which given. What is the reference angle for each one? Yeah, we can do this one because it is talking about reference angles. So we are given the angle, which is 170. So if I draw my x and y axis, so where is my 70? 170. This is 180. So 170 will be somewhere here. So my angle is this one. Okay, this is my theta, which is 170. And if I project my end arm on this axis, it will touch here. So this is my reference angle. Okay, so let's see, determine the measure of the 3 other angle in standard position. Okay, this one they are giving you the reference angle and you need to find the original angle. So in this case, for each angle you need to find three other angles beside this one, because you always know each angle can be itself a reference angle, and can be also an original angle. So you need to find the other three. For example, let us do for example this one. So we will draw our x and y axis like this. Okay, my 60 degree, I will suppose, so my starting arm is this, so, and my end arm is this. So this is my 60 degree, so this is my 60 degree, but you should remember it is a reference angle. So because it is a reference angle, this 60 degree can actually take 4 positions. So it can be there, it can be here, it can be here, and it can be here. So the first one, my first original angle, so theta is same as the theta r. The second one, which will be this one, my angle will be starting from here, starting from the x-axis and going up to touch my terminal arm. So this is a 60, that means this is a 30. So my original arm is 90 plus 30, which is theta plus 90, which is 120 degree. So for this position is 120. For this position, it is not. It is 180 plus 60. So for this position, it will be 180 plus 60. Okay, so I think all this is good. This is just some other application. We can go over them if you have any question.